All right, these two problems, they look really, really large, right? And tough, but they're really not. I mean, right away, I see two numbers that go into this guy. What two numbers? 3. How do you know it's 3?
Because 3 goes into 12 and 3 goes into 15.
You were listening the other day. So you broke it down into two pieces. I like it. You're like, hey, wait, this is a 3. This is a 6. Those are numbers that 3 go into. So I know that 3 goes into that number. You don't have to add up the whole number, right? You don't have to add up every number. You can see a pattern. The other number I see that goes into this is 5, right? Because the trick is zeros and 5. And the number I know that doesn't go into it is 2. Does that make sense? Okay? So honestly, I know that 15 goes into this because 3 and 5 go into it. But I don't want to start with 15. It's not finding the largest, greatest common factor. It's about just finding factors. And that's why we start with given. Okay? That's our first step. Every time. Okay? And then our second step, let's break it down. So we know there's a 13 out there, right? Times the rest of this. So we're going to break down what is 12, 15. And you just said, hey, I'm going to go with a 3. Right? Oh, and by the way, this is prime, the definition of prime factorization. Alright, and so 3 goes into 12 4 times. 0 left over. 3 goes into 1, and this is where it gets a little confusing. Some students I've seen miss this because they're like, they go, well, yeah, 3 goes into 15 5 times. So it's just 45. But what they forget is like, wait a minute, man, 3 times 45 is not 1,200. Right? So at that point, you should be like, something's wrong here. And what they forgot was, well, 3 doesn't go into 1, right? And that got actually carried over and turned into a 15, right? And so it's really 405. And then they're like, okay, well then I should try another 3, right? And does 3 go into 40 or 4? Sorry, 4.
No. Oh, yeah.
1, right? With 1 left over. And does 3 go into 10?
3 times. With
Right?
1 left over.
So let's change the color again. 3 goes into 4 once with 1 left over. 3 goes into 10 3 times, right?
Yep.
With 1 left over, right? And then 3 goes into 15
5 times.
5 times. Does that make sense? A little bit? Okay. This is what I call short division. It's upside down short division. So we're doing what I call upside down division. That's the upside down division bar. Then we're doing short division where we're saying, hey, we're putting these little markers up on top to let us know what our placement is. Okay? Alright, let me use a different placement color because maybe the color isn't right. So let's go, does 3 go into 1, 3, 5? So think about that. 1 and 5 is 6, right? And 3 is 3. And 6 and 3 are both numbers that 3 go into, right? So 3 should go into this number. Does that make sense? So 1 and 5 is 6. 3 is a 3. So 6 and 3 are both numbers that 3 goes into. So therefore, it goes into 135. Now if you add it up, 1 plus 3 plus 5, you get 9. So any way you want to do it, you see what I'm saying? You can look at it complicated. Oh, that's a 6 and a 3, good. Or if you can look, you just want to add it up. Sometimes it's easier to just add it up. So like when she saw this, it was easier to go, oh, 3 goes into both of those numbers, so 3 goes into the big number, right? All right, so 3 goes into this. How many times does 3 go into 13? 4, good. And then there's 1 left over, right? Okay? And so I'm going to change this color, right? So I go, okay, 3 goes into 15 now. Because that was 1 was left over, right? So 3 goes into 15 5 times, good. Okay? Now it's starting to get easier. Now I could keep it in one color, but I know a lot of other students don't see that 15 goes into 45 3 times, right? So we can change the color, and then go 3 goes into 4 once, with 1 left over, right? And then 3 goes into 15, 3 goes into 15 5 times. And so I get 15. And then does 3 go into 15? Yeah. Now we don't have to change our colors because we know it's 5. And then does 3 go into 5? No, but 5 does. So we just keep using our primes, okay, until you get to 1. And these are your primes. And that's why this chapter is really important to have your primes in your cheat sheet. 2, 3, 5, 7, 11, 13. Super important. Okay? Now, here's the coolest part. Seriously. Take a color, any color you want. I like red. Make your circles. Now, let's use green, because I already used red, purple, blue. So let's use green so it stands out. I'm just picking the pairs. Just the pairs. And out of each pair, I'm going to bring 1 out. Out of each pair, I'm going to bring 1 out. But anything not in a pair, I'm going to leave in the box. Right? But we can't forget that we started with this 13 outside of it. Does that make sense? So what we just did after, when we took these 3's out, is we simplified the radical. Okay? So that green part is simplifying the radical. And if you want to start writing radical instead of radical simplifying, whatever floats your boat. Right? Okay. Then, because when you get to the end on the state test, what I really want you to be able to do is write in words all of this. You're going to say, the first part they gave me, then I did prime factorization to break down the radical. Then I simplified that radical. And you're writing this in words, you see what I'm saying? And that's going to be the difference between almost passing the state test and passing the state test. Okay? Alright, next. Now we want to PIMDOS this, right? PIMDOS. So we want to do, exponents, parentheses, all that stuff. Well, we want to get these together. So I know that that's really the square root of 15, right? Now I want to get these together, so I know that that's 9. And so that's 13 times 9 square roots of 15. So right there, all I did is simplify, or this one's more simplify than it is distribution. And the next one is more distribution than it is simplification. Okay? Because we're actually going to be multiplying this in. These we're just multiplying 2 things together. This one we're going in. So what is 13 times 9? So let's use that method again. What's 13 times 10? What's 10 times 9?
90.
90. Okay? And then what's 3 times 9?
27.
27. And then just add those in your head. 27 and 90.
117.
Boom. So we got 117 square roots of 15. You see how that works? So I love doing this breakup of 9 times 10 plus 9 times 3. And all we're doing is splitting that number up and using easy numbers, 10s, 20s, 30s, stuff like that. Okay? And I think that's done. I'm going to actually stop that film. That was actually kind of long, but it was really good, I thought.